To problem 5, consider the function fx equals negative 2x cubed plus 45x squared minus 300x plus 2. This function has two critical numbers. We need to first find them, then find their values at second derivative, you see. All right, let's figure this one out. So, this is my fx, okay. Now let me find its derivative. Negative 6x power 2 plus 2 comes down, that is 90x minus 300. Okay, so that tells me f prime x looks like I can get a negative 6 common. Yeah, 6 is common and I'll get the sign out to get rid of this. So that gives me x to the power 2 minus, do you understand why minus? Negative times a negative is a positive, okay? 15x plus, because I got the negative out, negative times positive is a negative, okay? 50, okay? Looks like I can factor this. So let's try. F prime of x equals negative 6. You notice x minus 5, x minus 10 is the factorization of this quadratic expression. Okay, so that's good. When do you have a critical number? Well, we want f prime x to be equal 0 or f prime x to be undefined. Okay, this gives you critical numbers. Okay, one is easy, to be undefined. Look, you have no denominator, no square root, and there are no problems. So f prime is always defined. So this will not work. The only other option is f prime x equals 0. Well, that tells you x equals 5 is a solution from here. X equals 10 is a solution from there. X equals 5 and 10 are your critical numbers. So write the smaller one first, 5 and 10. Okay, these are your two critical numbers. Now we need to find second derivative of these two. So we already have first derivative. I will now find second derivative. Okay, so I'm using this because then I can directly take derivative rather than any of these, right? So that's a negative 12x plus 90. Okay, so let's figure out the value of these derivatives, second derivatives at my numbers. At 5, it is equals negative 12 times 5 plus 90, that is negative 60 plus 90, that is 30, which is greater than 0. Okay, that's good news. They have asked us for just the derivative as a value, so that is a positive 30, correct. Now, the second one. Okay, f double prime at 10 equals negative 12 times 10 plus 90 equals negative 120 plus 90 equals negative 30. So that value is a negative 30. Now, which brings us to my f, correct? So, look, this tells what is the matter with it. Why do we need second derivatives anyway? Second derivatives determine concavity. Okay, so f double prime greater than 0 means, okay, means f is concave up. f double prime less than f double prime less than 0 means f is concave down. That's all. That's the important part. So let's draw our picture. Some idea. You have 5 and 10. Okay. So draw some line. Okay. You see, I don't care for the value. I just want to know whether it's a local max or minimum. Somewhere is 5. Somewhere here is 10. Okay. We know they are both critical numbers. What does that mean? They have horizontal tangent. Okay, each. I don't know where their values are, but pretend it's something like this. At 5, you are concave up. So your curve should look like this at 5. We don't care what it does later or before, but at 5, it should look concave up. At 10, it is concave down. Negative second derivative means it's concave down. It's something like this. Okay, we don't care what it does somewhere else, but here it's concave down. Okay. So what does that tell me? At 5, I have local minimum. And at 10, I have local maximum. All right, until next problem.